Seen from space, Earth reveals a defining characteristic unlike any other known world in our solar system. Vast oceans dominate its surface, giving the planet its unmistakable blue appearance. This immense reservoir of water, known collectively as the hydrosphere, extends far beyond the seas. It includes rivers, lakes, glaciers, groundwater, clouds, and even the water contained within every living organism. Together, these interconnected reservoirs form one of Earth's most dynamic systems, shaping climate, landscapes, and the evolution of life itself. Viewed from space, Earth appears as a blue planet. More than 70% of its surface is covered by water, a feature unlike any other known world in our solar system. Yet this vast abundance conceals a remarkable reality. Around 97% of Earth's water is saltwater contained within the oceans. Less than 3% is freshwater, and the overwhelming majority of that is locked away in glaciers, polar ice sheets, or stored deep beneath the ground. Only a tiny fraction exists in rivers, lakes, wetlands, and the atmosphere. Yet this small reserve supports nearly all terrestrial life. The story of the hydrosphere begins over 4 billion years ago. During Earth's earliest history, the young planet endured relentless volcanic eruptions and frequent impacts from asteroids and comets. As volcanic gases escaped from Earth's interior, enormous quantities of water vapor entered the atmosphere. Over millions of years, the planet gradually cooled. Water vapor condensed into clouds, and rain began to fall. Not for days or years, but for thousands, perhaps millions of years. Rainfall accumulated across the planet's surface, filling vast depressions that would become the first oceans. Additional water may have arrived aboard icy comets and water-rich asteroids, contributing to the reservoirs that still exist today. These early oceans became the cradle of life. Within their mineral-rich waters, simple organic molecules combined into increasingly complex forms. Although scientists continue to investigate the precise origins of life, the evidence consistently points toward aquatic environments as the setting in which the first living cells emerged more than 3.5 billion years ago. Every plant, animal, and human being can trace its ancestry back to these ancient waters. The oceans remain the largest component of the hydrosphere and dominate Earth's climate system. Covering more than 360 million square kilometers, they absorb enormous amounts of solar energy during the day and gradually release that heat back into the atmosphere. This capacity moderates global temperatures, preventing the dramatic extremes experienced on planets without extensive bodies of liquid water. Ocean currents extend this influence across the globe. Driven by winds, Earth's rotation, and differences in temperature and salinity, these immense rivers within the sea transport heat from the tropics toward the poles while returning cooler water toward the equator. The result is a global circulation system that shapes regional climates, influences rainfall, and supports marine ecosystems thousands of kilometers from its point of origin. Above the oceans, another remarkable process unfolds continuously. Solar energy causes water to evaporate from the sea, lakes, rivers, and soils. Plants release additional moisture through transpiration, adding billions of tons of water vapor to the atmosphere each year. As warm, moist air rises, it cools, allowing microscopic droplets to condense into clouds. Winds carry these clouds across continents before precipitation returns water to the surface as rain, snow, sleet, or hail. Some of this water flows directly into rivers, some infiltrates the soil, replenishing underground aquifers, while the remainder eventually returns to the oceans, completing what scientists call the hydrological, or water, cycle. This cycle has operated for hundreds of millions of years, continuously recycling the same water molecules through different environments. A single drop of water may spend thousands of years frozen within Antarctic ice before melting into the ocean, evaporating into the atmosphere, falling as rain over a mountain range, flowing through a river, nourishing a forest, and ultimately returning once again to the sea. Freshwater systems occupy only a small portion of Earth's surface, yet their importance is immeasurable. Rivers carve valleys, transport sediments, and create fertile floodplains that have supported civilizations for thousands of years. Ancient societies flourished along waterways where predictable flooding replenished agricultural land and enabled the growth of complex cultures. Lakes serve as natural reservoirs, storing fresh water while supporting countless species of fish, birds, and aquatic plants. Wetlands perform an equally vital role, filtering pollutants, reducing flood risk, storing carbon, and providing habitat for an astonishing diversity of wildlife. Although they occupy relatively small areas, wetlands rank among the most productive ecosystems on Earth. Hidden beneath the surface lies another vast component of the hydrosphere. Groundwater fills tiny spaces between soil particles and fractures within rocks, forming aquifers that supply drinking water to billions of people. In many regions, groundwater sustains agriculture during periods of drought and maintains river flow even when rainfall is scarce. Because this resource is largely invisible, it is often overlooked, despite representing one of humanity's most valuable freshwater reserves. At Earth's poles and on high mountain ranges, water exists in its solid form. Antarctica alone contains roughly 90% of the world's ice and around 70% of its freshwater. Greenland holds another immense ice sheet, while thousands of glaciers extend across mountain landscapes from the Himalayas to the Andes and the Alps. These frozen reservoirs regulate river systems, influence sea level, and preserve detailed records of past climates within layers of ancient ice. Water also exists in the atmosphere, although in comparatively tiny quantities. At any given moment, only a small percentage of Earth's total water is suspended as vapor or cloud droplets. Despite this limited volume, atmospheric moisture drives weather systems across the globe, distributing fresh water far beyond the oceans and shaping ecosystems from tropical rainforests to temperate grasslands. The hydrosphere is intimately connected with Earth's other planetary systems. It interacts constantly with the atmosphere to regulate climate, with the lithosphere to shape landscapes through erosion and sediment transport, and with the biosphere by sustaining every known form of life. These systems do not operate independently. Each depends upon the others in a continuous exchange of energy and matter that has maintained Earth's stability for billions of years. Human civilization has always depended upon the hydrosphere. Water powers industry, irrigates crops, generates electricity, transports goods, and sustains public health. Nearly every major city developed near reliable sources of fresh water, reflecting the enduring relationship between human societies and the movement of water across the landscape. Yet the hydrosphere is increasingly influenced by human activity. Rising global temperatures are accelerating glacier retreat, warming the oceans, and altering precipitation patterns in many regions. Sea levels continue to rise as ice sheets lose mass, and seawater expands with increasing temperature. Pollution from plastics, chemicals, and agricultural runoff affects rivers, lakes, and marine ecosystems, while excessive groundwater extraction places growing pressure on freshwater supplies. These changes illustrate the delicate balance upon which Earth's water systems depend. Despite these challenges, the hydrosphere remains one of the planet's most resilient systems. Every day, evaporation, condensation, precipitation, and flow continue the cycle that has sustained life since Earth's earliest history. Water links distant continents through atmospheric circulation, connects mountain glaciers with coastal estuaries, and unites every living organism within a single planetary network. The story of the hydrosphere is, ultimately, the story of Earth itself. From the formation of the first oceans to the rise of civilizations and the complex global systems of today, water has shaped landscapes, climates, ecosystems, and the evolution of life. Every river, every cloud, every glacier, and every ocean current forms part of an interconnected system that has endured for billions of years. It is a reminder that the planet's most familiar substance is also one of its most extraordinary, a force that continues to define the past, sustain the present, and influence the future of our world.